Alright guys, last day of video learning. I don't know about you, but I'll be glad to get back into the classroom. It's be much easier for me. I'm not sure about you, if it's easier for you or not. But here's the questions for homework that you had to do. You had numbers 1 through 37, every other odd. And number 43. So we want to look at these. Number 1, they're asking for the point that will satisfy the mean value theorem. So again, here's my endpoints. So I figure out what my y's are. If I have my endpoints, I put 0 in, I get -1. I put 1 in, and I get 2. 1 squared is 1. 2 times 1 is 2. 2 plus 1 is 3. 3 minus 1 is 2. So here's my points at the ends of that graph. This is a continuous graph. Alright, it's part of a parabola. And it is closed, so the extreme value theorem applies. It is continuous, so the mean value theorem applies. So there's somewhere along that curve that the slope of the tangent line will be equal to the slope of the secant line. So that's what we're trying to find. We're trying to find that point. So we're going to take the derivative of this function. Here's the derivative. F prime of x equals 2x plus 2. Right, we plug in c for x, and here's my average value for my secant line. So this is the slope of my secant line, -2 minus -1 over 1 minus 0. So it's not 2 minus 1, but that should be 1 minus 0. I don't know why I put 2 minus 1 there. I looked at the wrong thing. 1 minus 0, which is 1, which is still 3. So I messed up there. I didn't even notice that when I was doing it. So that's 3. Okay, so this would equal this. Mean value theorem says f prime of c equals f of b minus f of a over b minus a. So this equals this. So 2c plus 2 equals 3. And I'm solving for c. So the point on the graph where the slope of the tangent line would equal the slope of the secant line is at 1/2. So halfway between 0 and 1. So that's what they're looking for. If you wanted to find the point on the graph, then you plug 1/2 in. 1/4 plus 1 minus 1, which would be 1/4. So 1/2, 1/4 would be the point. Alright, here, number 7, they're doing the same thing. So we got a piecewise function. You get cosine x between 0 and pi over 2. We get sine x between pi over 2 and pi. First of all, I want to see if this is continuous. So we plug in my point of intersection here. So put pi over 2 in for cosine x. Cosine of pi over 2 is 0. And the sine of pi over 2 is 1. So we really have a jump discontinuity here. So it's discontinuous at pi over 2. So it does not satisfy the mean value theorem. So you don't have to do anything else for that. Number 13, they asked about the average speed of this boat. They asked if the speed of the boat would be over 7.5 nautical miles per hour. So first of all, we find the average speed. Okay, 184 over 24, so 184 nautical miles over 24, we get 7.7 nautical miles per hour. It is a continuous function, and according to the mean value theorem, there is a point where the slope of the secant average here is equal to the rate or the slope of the graph. So yes, there is some point along the way where that boat went faster than 7.5. Because my average was 7.7. So it went 7.7 somewhere along that graph. So that's what they were talking about there. And again, so this is the slope of my secant line. Alright, and the mean value theorem says on that graph there is a point somewhere where the slope of the tangent line, which is my instantaneous velocity, instantaneous rate of change. Slope of the tangent line is equal to the slope of the secant line. The secant line is 7.7, so there's a point there on that graph where that instantaneous rate was 7.7. Number 19, they're looking for where is it increasing, where is it decreasing, and any critical points or extreme values. So I'll take the derivative 2 to e to the 2x. All right, set it equal to 0. E to the 2x equals 0. Well, this is a exponential function, so we know that goes this way, where I have a horizontal asymptote at 0. So therefore, I know that e to the 2x never equals 0. Plus, if I go algebraically, 2x equals log 0. That is undefined as well. So there's no critical points. All right. So when we put back into my graph here, e to the 2x, that graph goes here, and we notice it's always increasing. So no matter what number I put in here, if I put a positive in, or if I put a negative number in, this value is always positive. So therefore, it's always increasing from negative infinity to infinity. So that one there. All right, so here we have h of x equals negative x over x squared plus 4. And again, we're looking for extreme values, and we're looking for increasing and decreasing. So we go ahead and take the derivative by using the quotient rule, and I get x squared minus 4 over x squared plus 4 squared. Well, what makes this 0 is the numerator. So I'm going to check, where is the numerator 0? Well, the numerator is 0 at 2 and negative 2. So I have critical points there. So I have extremes at 2 and negative 2. So that's what the values I'm going to use. So I put negative 2 and 2. I pick a number to the left of negative 2, negative 3. I can pick any number I want. In between negative 2 and 2, the easiest one is 0. And to the right of 2, and this should be a plus 3. And again, I was doing this fast and I messed up. So this is a plus 3. Okay, plus 3. I can't change it on my slide right now. So plus 3. All right, so I plug these into my derivative here. So if I put a negative 3 in here, that's 9 minus 4, which is 5. Put a negative 3 in here, that's 9 plus 4, which is 13. 13 squared is 169. 5 over 169. When I put negative 2 in, I notice that it equals 0. Put 0 in, I get negative 4 over 16, which is negative 1/4. Put 2 in, I get 0. And if I put 3 in, 3 squared, all right, same thing. And so I get 5 over 169. So in the derivative, we learned that when the derivative is positive, I'm increasing. When the derivative is negative, I'm decreasing. And when the derivative is positive, I'm increasing. So if I look at my derivative, the graph on my derivative here, here's negative 2, here's 2. I am increasing to negative 2, decreasing from negative 2 to 2, increasing from 2 to infinity. So now I can do my increasing and decreasing. I know that I have a local maximum at negative 2, so when I put negative 2 into my original function, that's negative 2 is 2, 4 plus 4 is 8, 2 over 8 is 1/4. So I have a local maximum right here of 1/4 at x equals negative 2. At 2, I have a local minimum by looking at my graph. And again, I don't have to do this on a calculator. I can just do it by what my table is saying. Put 2 in. Here. Negative 2 over 4 plus 4 is 8. Negative 2 over 8 is negative 1/4. So I have a local minimum of negative 1/4 at x equals 2. Where am I increasing? From negative infinity to negative 2. And again, the endpoints are included, increasing and decreasing. From negative 2 to 2, I'm decreasing, and from 2 to infinity, I'm increasing. All right, so here's my derivative graph. Tells me increasing, decreasing, and so on. When I look at that. Okay, and again, my other graph would look different than this. This is just a derivative graph, so I can see where the slope is increasing, the slope is decreasing, and so on. And again, my derivative graph wouldn't necessarily look exactly like this. but it gets the job done. Number 31, they're asking for the antiderivative. So the antiderivative, we're going to add 1 to the exponent, 3, divide by it. 3 divided by 3 is 1, so x cubed. Add 1 to the exponent, divide by it. So 1 plus 1 is 2, divide by 2, all right, is 1. So x cubed minus x squared. This is x to the 0, so add 1 to it. That's 1, divide by it is still 1, so that's x. And then I always have to add the at plus c to my antiderivative. Just a little hint, this is the track that we're heading for integrals. As we take integrals, the integral is actually the antiderivative. 37, again, they're looking for the antiderivative of 1 over x plus 2, okay? And we want to find the equation that goes through negative 1 and 3. Well, I have to recognize that this is a special function. This is the result of a logarithm, natural log. So if I go backwards, all right, the logarithm that was taken was x plus 2. So I look ln of x plus 2 plus c. I just double check. If I was taking the derivative of this, what would I have? 1 over x plus 2 times 1, which is what I have. So we're good. Here's my antiderivative. I want it going through negative 1 and 3, so I'll put 3 in for x. 3 in for the y, f of x. Put negative 1 in for the x. All right, solve. I get ln 1. Well, what do I take the derivative? What is the exponent of e that will give me 1? Well, that's 0. Log of 1 is 0. 0 plus c is c, so c equals 3. So here is there is my function. And if I took the derivative of this, I should get this. All right, x plus 2, the domain of x plus 2, it has to be greater than negative 2, because I can't take the logarithm of 0. All right, number 43 was a word problem. All right, they start out saying that the acceleration due to gravity is negative 1.6 meters per second squared. So there's my function, a equals negative 1.6. And we learned that the derivative of position is velocity. The derivative of velocity is acceleration. So here we're just working backwards. So first of all, I want to find the equation for velocity, so I take the antiderivative. This is t to the 0, add 1, divide by it, so v equals negative 1.6 t plus c. Well, when we're just dropping it at time equals 0, the velocity is 0, right? Because we're dropping it, so we're holding it in our hands, so at t equals 0, velocity is 0. So I'll put 0 in for my velocity, 0 in for my time, and I find out that c equals 0. All right, so here's my velocity equation. V equals negative 1.6t. Then I can find my position equation by taking the antiderivative of this. All right, so I'm going to add 1 to my function, which is 2, divide by it is negative 0.8 t squared plus c. All right, so now it says it takes 30 seconds to hit the bottom. So at 30 seconds, my position is 0. So I'm going to put 0 in for my s. I'm going to put 30 in for my time. And this equation here to find out what the c is. 30 squared is 900. 900 times negative 0.8 is negative 720. C equals 720. So here's my position equation. All right, so letter A, they ask what is the speed as it just before it hits the ground. All right, that's 30 seconds. So I put that into my velocity equation. Negative 1.6t, 30 times negative 1.6 is negative 48. So that's going 48.0 meters per second just before it hits the ground. Letter B, it says how far is it from the release point is the ground. All right, 720. We already figured that out, 720. Now letter C. Letter C said, okay, instead of just dropping it, we threw it down. So therefore, We're going to do the same process. Negative 1.6, antiderivative, negative 1.6t plus c. Well, when time equals 0, the velocity is negative 4. Alright, so I put negative 4 in for v, put 0 in for t. I find out that c is negative 0.4. So here's my velocity equation. I can find position by doing the same thing. Add 1, divide by it, negative 0.8 t squared. Add 1, divide by it, negative 4t plus c. Well, I know my original position is minus 720, so when I take it over here, here's my equation of my position, 720. All right, so letter C, they ask, well, how long does it take to hit the ground? So I'm going to take this equation and solve for t when I get s equals 0. So I use my quadratic equation. All right, I find out that I get, going through the math, put 720 in for c, put negative 0.8 in for a, times negative 4, times plus b squared, all right, divided by negative 1.6, because 2 times a, I find out I get 27.6 seconds and negative 32.6 seconds. Well, I can't have negative 32 seconds, so that's not the answer. So my answer is 27.6 seconds, the amount of time it takes to hit the ground. Then they ask, what is the velocity? So I'm going to put the 27.6 seconds into my velocity equation, which I found earlier, all right, and it gives me negative 48.16 meters per second is my velocity equation. Okay, so that's how you do those. All right, so what I want you to do tonight, or today, is to do, and there's really one more problem there I want you to do. So let me find out what that is. Hold on. So I want you to do those problems there, and I also want you to do, write that one down. .44. So 6, 10, 16, 22, 28, 32, 36, and 44. Okay? So 6, 10, 16, 22, 28, 32, 36, and 44 on page 202.